Good morning, students. How are you doing today? I believe you are doing great. Last class, we discussed how to find the length of a chord, the radius, and the distance from the center to the middle point of a chord. Now, stating the first theorem, which states that a straight line drawn from the center of a circle to the middle point of a chord, which is not diameter, is at right angle to that chord. Now, today we are going to look at theorem 2, which states that the angle that an arc of a circle subtends at the center is twice that which it subtends at the circumference of a circle. Simply put, angle at the center of a circle is twice angle at the circumference. So let's see it. What do we mean by when we have arc? What do we mean by arc? Don't forget, I explained what we mean by arc using the plates last class. Like you can see, from here to here is one arc, from here to here is another arc, from here to here is another arc. So let's look at a circle. This is a circle. Let's say this is the center of a circle. Now, from this circle, if I have arc AB, this arc here, from here to here is one arc. Are you getting it now? So if I want to subtend at the circumference, now the angle of this arc is inside here. The arc AB will take this angle. Let me call it theta. Now, the angle theta here is the angle that this small arc is having. Now, if I have a straight line drawn to the circumference, you can see this is a circumference from the arc AB. So from A, I move to circumference. From B, I move to circumference. So I will form another angle. Let me call it beta. Do you get that now? Okay, let me change it. Now, if this is theta, and this theorem states that the angle at the center is twice angle at the circumference, that means this is going to be theta all over 2. If this is 2a, this angle here is going to be a. If this angle here is 100, this angle here will be 50. 100 divided by 2. So take note of that. Let me draw another diagram. This is the center of a circle, PQ, 0. Now, you can see I have another arc, PQ. Now, there's what we call a reflex angle. Now, POQ, taking theta into consideration, is one angle. Now, the reflex angle that we have is this angle here. You know that angle at a point is 360 degrees. So, the reflex angle POQ is this angle here. So, if, for example, this place is 100, and you are asked, what is the reflex angle? You just say 360 degree minus 100. So, the reflex angle here is what? 260 degrees. Do you get that now? So, in this diagram, if we are not going to obey angle at the center, twice angle at the circumference. Now, for this small arc, I'm going to subtend to circumference. So, that means from this arc PQ, I move to circumference. I can move to anywhere on the circumference of the circle. Here. Are you getting it now? So, if I move like this, you can see I locate a point on the circumference. Now, this Q, we also join this. I have another angle here. So, diagram can be anyhow. This is stating that angle at this center is twice angle at the circumference. So, if this is 100 now, this is going to be 50 degrees. Do you get that now? I can decide to move my own circumference to this place. Look at it. This is still going to give me 50 degrees. So, anyhow, on the major arc, do you get that? So, angle at the angle that and the small arc subtend at the center is going to form angle at the circumference on the what? Major arc. While on the major arc is going to subtend to what? The circumference of the small arc. So let's see that. Let me send this.